Hello guys, so welcome to our lab 3. In this lab, we're gonna see, slightly more complicated assembly program. This program adds 5 numbers together. So we're gonna have a loop here, So because, with 5 numbers, you can have 5 lines of code that add, each number to some location like AX, some register. But if you have 100, numbers to add together, an array of 100 numbers or 1,000 numbers or 1 million. So we need some kind of looping. And in this, particular lab, we're gonna, see one kind of making a loop. And this, will depend on, the jumping instruction that we see, slightly in our lectures. So let's go to the code and check, we in our last lecture, we explained what that, part of the code means, okay? Then it comes to the data segment. So in here, we are defining 2 variables in the data segment memory. One variable called data n, this variable here, okay? And this variable is actually an array. And each element in that array is of type word. I mean, it's 16 bits. And since in our memory, each, or our memory is divided into bytes. So each element in that array takes 2 bytes. And in the first byte, there is 1 hexadecimal, second byte again 1, third is 1, fourth is 1, and finally the 5th location is also has. Although here 1 is just 1 bit, but we choose word as a size for each element. Maybe in the future we're gonna change data in and makes it makes each element a little higher than 8 bits. So that's why we choose word. Then we define a variable. This variable now is not an array, it's just a normal variable, again of size word, and we didn't initialize it. So we put just, question mark. So for any variables that you don't want to initialize, you just put a question mark. Okay. Then it comes to our code. So this is our code segment. And we said also this part is in black and that part doesn't change, but what's in between here, change based on your application. In our application now, we want to add these, 5 elements together and add the result in this variable called the sum. Okay, so we said that we want to make loops. We want to apply some kind of looping. So we want to loop over these, values here. Okay, and looping in assembly is tricky because this is not a high-level language that you have, for loop or something. No, here it's a little bit tricky and more complicated, or more restricted, we can say. It's a low-level, very low-level language. So what we're gonna do first is we define the number of loops. Since we want to add 5 elements, we will have 5 iterations, we can say. So we're gonna store the number of iterations in CX. So we said move CX and 5. And remember, assembly is not case sensitive or insensitive to cases, to letter cases. So move as small letters like move as capital letters. So don't worry about that. Also, CX can be written in that way as capital letters or or small letters. You can mix capitals with small. That's also okay. Then we want to refer to the address. Since data n is stored in the memory, we want to locate or point to the first location of the array data n in the memory. And we do that using the offset keyword here. So offset is a keyword. Okay, so when we say move EBX offset data n, we said, hey, please give me the first address, means the first address of that element here, the first byte basically, and put it in EBX. If you remember, guys, from our lectures about registers, we said that EBX can be used as an offset. And that's exactly what we are doing here. we store the offset register, the offset address of the first location of data in ABX. We don't know this. We want to know. We will know once we execute our program. Then we since we want to accumulate the addition or the summation of these values into sum, first we're gonna accumulate the values into a register called AX. Then at the end, after doing the 5 iterations, we will move what's in AX into sum, as we will see in a moment. So the first line in our loop. So we put a label because this code here from that location to that location will be repeated 5 times. Okay, so or we can say that add AX and EBX will be repeated 5 times. First, we're gonna add this one, this one, this one, so 5 times here. So since this will be repeated 5 times, we're gonna add a label, and we're gonna see how we will use the label afterwards. Okay, now after that iteration here, what we have done is basically taking the address or going to the memory. Since we put EBX between 2 brackets, that means, hey assembler, go to the the location or the address that is now pointed to by EBX and get what's in there and put in AX. So what's in there is a byte, which contains the 1 hexadecimal, and this will be stored in AX. Good. Now we need to refer to this location, the second location. Remember that each element here is a word, 16 bits or 2 bytes. So each byte has an address. So now EBX has the first address here. Okay, the first byte of that guy. So we want to increment EBX 1 time, so we refer to the second address of the first element. The first element, although it's one hexadecimal, which is 8 bits. 8 bits is enough for it, but it's of type word, so it consumes 2 bytes of the memory. So we want to increment EBX one more time, so we refer to the first byte in the second element of the array data in. Okay, then we decrement CX, so CX will be 4, and since CX doesn't reach 0, then the flag register, you guys remember the flag register? In the flag register there is what's called the 0 flag, a bit which become 1 if the last operation results in a 0, but the last operation here results in a 4. That's not a 0. So since it's not a 0, we're gonna jump. So here we are saying jump if not 0, and it's not 0, so we're gonna jump to again. So we're gonna go here. What's gonna do here is that we add again to AX what's in EBX, or what's pointed to by EBX. What's pointed to by EBX now is the first byte of the second element, which is again 1 hexadecimal. So AX after this operation will be 2. Okay, and we're gonna do the same again and again until CX become 1. And in that time, decrement CX will be reduced by 1. It will reach 0. So the flag register, the 0 flag register, bit on the flag register will be 1 at that time. So it's now 0, not 0. So we will not jump, and we will move to this instruction. And in that instruction, we move what's in AX, and at that time, when CX reaches 1 or reaches 0, basically, AX will have 5, which is the addition of these 5 elements. So sum will be 5. In your, guys, in your report here, you're gonna, put the output of each instruction. Of course, some instructions, like these ones, for example, will be executed more than 1 time. So in this cell, the cell is big enough, so you can add, more than 1 value in that cell. So let's do this together. Here is the program on the left hand side of the screen. So in that program here, I made run to the cursor. So we are now stopping here. there is a good, feature here in Visual Studio. Since this window here only shows registers, and now we have memory locations that we want to track, there is a nice feature called, add watch. So whenever you, you click on any variable or a register, and you right click and add watch, it will have a copy of this or a track or a monitor of this register or variable in this window here, the watch window. Since we have CX, I will just, of course I did this before. Let me remove all of them. So delete watch again, and delete watch, and I'm gonna do them one by one. So move 6 and 5. First, I'm gonna add a watch here, add watch. So now this is the current value of CX. It's of course some junky value, some random values that it has before. And we're gonna move forward. Of course, after this operation, CX will be 5. Look, guys, it become 5. And now we are stopping it. So we're gonna put here 5. Okay, and luckily this line will just exceed one time, so you will not put anything else until the end of the program in that cell. Okay, now we have EBX and data in. So we click on EBX and right click and add watch. So EBX now, this register has some junk value again, and data in, which is our array, we can also add as a watch. And what will be seen in the watch here is the first location. So the first location has 1. Okay, this first location here. It will not show the other locations. So let's, of course, after executing that command here, EBX will have the address of the first byte in the array data in. So let's do that. Look, guys, so this is basically the address of the first location of the first byte, basically, of that element, the first element in data in array. Good. Now we are here, so add a watch again for AX, and of course we should here put this value, which is 1851392. And remember, guys, this is my computer, so this, don't expect that this number will be the same for you. It might be different. Most probably will be different. So don't take this number. You must run it in your computer and have a new number. Okay, so let's continue. Of course, AX will, after this operation, will be 0, and it's 0 here. Good. Now we are on the loop. So we will not add any watches because we already have EBX and we already have AX. So we're gonna just move forward. Of course, after this operation, AX will have 1, which is the value of the first element. Good. So here AX is 1. Now, since EBX is located or directed or pointing to the first byte of this location, this location is 2 bytes. So we wanna point to the first location of the second element. So we must jump by, or not jump, we must increment EBX by 2. Okay, so you can do 2 increments here. Okay, increment EBX, then another increment of this. So this will, after the first one, it will be 93, the last location here, and after the second one, it will be 94. You can also do add EBX and 2, comma 2. This is exactly the same. Okay, same as doing increment 2 times. Okay, so let's check the EBX after the increment. So the first increment, it becomes 93. It means the last two digits. Then 94. Okay, then we're gonna decrement CX. So CX is 4. It will decrement to 5. It will decrement to 4. Look, guys, it becomes 4. And since CX doesn't reach 0, so the 0 flag bit in the flag register is 0. So it's not 0, you know. So since it's not 0, you know, we're gonna go to, I mean, Cx is not 0. We're gonna go to again. Okay. Okay. Now let's check what will happen. So look, guys, we will not execute this. We're gonna go here. Let's check. 1, 2, 3. Look, we go back to again, the label again. So we're gonna do this again here. So of course, you should put the values of EBX. So I didn't do that. So 1851393. Then the second one is 1851394. So, and when we reach it again, we're gonna put the new value again, which will be 95 then 96. Okay, let's continue here. So now AX is 2 because we are pointing to the second element of the array, and so on. Okay, and so on. So this will be basically, you know, your turn to continue and put any values here. And for each iteration, you should take a screenshot for each iteration. So in the first iteration, take a screenshot. Once you reach here, take a screenshot of, you know, the values and show this. So these values, take a screenshot. Second iteration, once you reach here, take another screenshot of the values here. Third iteration, until the final iteration. When you move here, let's do that. Let's do, you know, I'm gonna go fast on this. This is the last iteration because Cx is 1 now. So once we reach here, Cx will be decremented and become 0. So it's not 0. It's a 0 basically. So this is not satisfied anymore. So we're gonna go to sum. In that case here, Ax is 5. So once we add, we need here to add, you know, a watch for the sum. So now sum after this command will be 5, and you put 5 here. Okay, guys, and of course you take a screenshot. This was basically, you know, the lab 3. Okay, it's interesting lab because you have the first kind of looping that we're gonna do in this course. So thank you very much and see you in the next lab. Bye-bye.